Hello and welcome to Unacademy, one-stop destination for civil services aspirants in English. I am Mukesh Jha. I have been an educator for the subjects of geography and environment and ecology and have had the good fortune of mentoring thousands of candidates in their journey for civil services. Today, we embark upon a new journey. With the launch of this series, we shall basically be discussing the topics of geography and environment and ecology relevant for the examination, be it for the prelims, for the mains, or even the interview phase. Why are we launching this series? The reason is very simple. The topics which are mentioned in current affairs from these particular areas oftentimes are so very daunting and factual in nature that the candidates are intimidated not only by the portion of the current affairs but by the subject in itself. So what we shall be doing is, we shall be picking up the various different topics, as complex as it may sound, and we shall be decluttering those particular topics for your better understanding. We shall be analyzing why they are important and what kind of questions can be asked from these particular areas in the examination. So today, we start the discussion with the topic Nor'easter strikes US coast. Now, this is a particular news headline which has been doing rounds for the past week or so. This has wreaked havoc in the region of North American coastline, and that too particularly the northeastern coast of North America. So in this video, as I have always told you, always try to simplify the topics and the portion in news. We shall be going behind this news. We shall be talking about what this is. So we shall be talking about what these nor'easters are. We shall be talking about how they are formed, the weather phenomena when they are created, right? And also the region where they occur. Are they observed everywhere across the planet, or is this a specific phenomena which is associated with the region of North America? So these are the various different key pointers that if you understand, I'm sure you will be able to address the questions in the prelims or even be able to write complex answers regardless of whatever is the word limit. So first of all, starting with the news headlines. So this is a story, as I have told you, has been making rounds for the past week or so. It has brought about a significantly harsh winter conditions in the northeastern coastline of the region of North America. And it is a large storm which has been brewing over the region for quite some time. Now, this is not something which has happened for the first time, by the way. This is a phenomena which recurs or repeats itself every 1 or 2 years. So here, you can see the news headlines about nor'easter rain, snow, and also travel bans and travel impact created because of the adverse conditions. But what is this weather phenomena about? So, always it is important to gain a visualistic approach first. If you take a look at the visualistic approach of what the storm is, you can see in this particular animation that this marks the northeastern coast of the region of North America. Now here you can observe the storm which is brewing, almost in a kind of a cyclonic formation. Now, this is developing on the margins of the land and the ocean in the region of North America. So why is it developing? What is the nature of this storm? Is this a normal cyclone, a tropical cyclone, or a hurricane that you have studied about? The answer is no. So let us understand what these storms are and why is it and how is it that they gain such a gigantic proportion where they can influence such a large area spanning a diameter of close to around 700 to almost 1,000 kilometers. And along with that, they bring winter rains. Snowfall is the most common form of precipitation which occurs during these months, and that reduces the visibility. But the very strong winds which accompany these storms, they can cause devastation of an unprecedented proportion. So first of all, why do they happen? So before we go into the details of it, one has to understand that this is a classic case of the surface phenomena interacting with the atmosphere and thereby leading to a complex atmospheric circulation. So this is impacted by the surface phenomena. Now, what surface phenomena are we talking about? So when we say surface phenomena here, we are talking about the influence of heating or cooling near the ground surface or the sea surface. Now here, what actually influences this is the ocean current. Now, ocean current to the western part of the Atlantic Ocean or to the east of North American coastline, that is in this region, you have one of the most powerful warm ocean currents present anywhere across the globe in the form of Gulf Stream. Now that Gulf Stream has got a very important role to play here. So the ocean current in action here is the warm Gulf Stream. So this warm Gulf Stream, what does it do? So its basic purpose or its basic functionality, if you will assume, is to bring warmer waters all the way from here near the region of the Florida coastline all the way to the northern portion of the Atlantic, and further this Gulf Stream basically transports water in the portion of the northern Atlantic in the form of North Atlantic drift and further subdivides itself into the Norwegian current, Rennell current, Irminger current and so on. But that is not important for this particular nor'easters. What is important for you to understand is that this particular Gulf Stream that you are able to see, this is bringing warm waters, right? Now, it is not very difficult to remember that, okay, Gulf Stream will bring warm water. Do I have to rectify it? No. Follow a very simple logic. If any ocean current is bringing warmer water or not even warmer water, if any ocean current is bringing water from lower latitude to higher latitude, it will be a warm ocean current, right? So when it brings water from lower latitudes to higher latitudes, from lower latitude to higher latitudes. So what will have? So whenever it brings water from lower latitude to the higher latitudes, it basically is going to be warmer current. And Gulf Stream basically combines significant amount of water coming from the region of Gulf of Mexico as well as the Antilles current. So it brings warm water in larger bulk, almost an unprecedented amount. And what you are able to see here is the thermal image. That gives you an idea about the warmer waters which are being brought about. Now, it is understood now that warmer waters are brought. So what? Now, these warmer waters will warm the air above as well. As these warmer waters are moving northwards, they will be warming the air above it as well, isn't it? So, by warming the air above it, it creates a region of warmer air mass which has got a tendency to move northwards, right? Keep that in mind, that it will have a warmer air mass which will have a tendency to move northwards. So, as a result of that, warmer air mass with a northward movement. But warmer air mass in itself, can it initiate or trigger a storm? The answer is no. And that too in the temperate area. This is not the tropics anymore. We are talking about higher latitudes now. So in these higher latitudes, what needs to happen is that these warmer air mass in itself will not trigger that much of a storm. But then when it mixes with a colder air mass or any air parcel which becomes very, very cold, that is when there is creation of a front. And that frontogenesis is where lies the genesis of the storm or the nor'easters that we are talking about. So basically, if you will observe here, what actually happens is that, observe, the warmer air is being brought by this Gulf Stream. At the same time, colder air from the region of the Arctic, they are coming southwards. Why? Because it is the winter season. In the winter season, the polar region becomes very, very cold. And that is when the high pressure in the polar region, which is a thermal high pressure, becomes much more stronger. From there lies the genesis of these very strong cold winds which start moving towards the lower latitudes. So that is where the cold winds from the Arctic, these are your cold winds from Arctic. Why are the winds blowing from the Arctic? Very simple. Because there is a thermal high pressure. Thermal high pressure means that a high pressure created due to very cold conditions. So these cold winds from the region of the Arctic, they start migrating slightly to the south. But there is another complicated role here, and that role is played by the jet streams. So as you observe these jet streams also along its northern boundary will start bringing this cold air. And observe the meandering of the jet stream. Jet streams follow what is referred to as a typical Rossby wave. So here, as these jet streams, they meander from the region of the portion of western and central Canada, they start coming and bringing cold winds from the region of Canada. They start bringing them to the region of the lower latitudes. And that is when, closely across the area of around Georgia and the eastern coast of United States, there is that creation of a front. And it is with that frontogenesis. Frontogenesis in simplest of the terms, the birth of a front, the creation of a front. So that creation of a front eventually leads to a storm. But how can the creation of a front lead to a storm? So that is where let us understand and analyze this. But before that, a thermal image of the cloud systems that you observe and the atmospheric systems. See, it is very important, always very important, to have a visualistic approach when you are studying the subject of geography. If you follow this subject like a very textbook fashion, how you follow the subjects such as history or polity or so on, then geography won't be able to come to you, and you will find significant amount of issues in understanding the complex problems. So that is why you have to understand and take the help of various images here. Now here what you observe is the air circulation. Observe the warm winds coming and also the cold winds coming. There is that unique mixture. Now these cold winds which are coming, these cold winds would bring about snowfall and significantly heavy precipitation. Why heavy precipitation? Because these are coming from the region above the water bodies. So thereby they would have significantly picked up huge amount of moisture in the process, and that moisture would be dropped and deposited, and there would be precipitation on the regions where they are influencing it, all the areas to the eastern part of US and even the eastern portion of Canada and the Canadian coastline. So here you have to understand the process of frontogenesis. That is the creation of a front. So till now, what is it that we have established? That warm air is brought by the Gulf Stream and you have cold air coming from the region of the Arctic. So what? So that is where lies the details of it. But before that, the simple definition. What are these nor'easters? And what is their characteristic? So a nor'easter is a storm. What kind of a storm? So here we can say it is a kind of an extratropical storm. Basically, meaning that it develops beyond the tropics. So it is a kind of extratropical or a temperate storm. Right. So that extratropical storm that forms along the east coast of North America. Why only the east coast of North America? Because this is where that unique mixture of the warm air and the cold air mass is going to happen. Nor'easters are named after the direction from which the strongest winds typically blow. The strongest winds are the cold winds in that region. They blow from which area? Which direction? Northeast. Winds are always named after the direction from where they originate or the direction from which they are blowing. Hence the name easterlies, westerlies, etc. So here, because the majority of the strong winds are coming from northeast and then moving towards the western direction, hence the name nor'easters. These storms can bring wind, snow, rain and flooding to these areas. So the impact is devastating. Now let us understand the genesis of the storm. How does the storm germinate, or how does this storm come into existence? So for this, first of all, you have to understand that whenever you have a warm and a cold air mass and they come head to head, there can be various different types of fronts which get created, right? So for example, let's suppose you have a region where from one area you have the cold air which is coming in, and from another area, let's suppose you have the warm air which is approaching. So this gets created as a front. Front is basically that zone of transition or that boundary area. So this process is what is referred to as the creation of a front. That process is what is referred to as frontogenesis. So the birth of the front, that is known as frontogenesis. In order to understand this in greater detail, and in order to have a detailed explanation of it for those who are uninitiated in this particular area of air masses and fronts, I urge you and I request you, do join us for the special session which shall be held today at 8 p.m. At 8 p.m. to 9:30 p.m. every day we hold some special session conceptual portions for geography and environment and ecology. So do join that special session on our app. And today we are going to hold that particular discussion about these nor'easters, frontogenesis, frontolysis, dissipation of the storm, etc. But coming to it briefly, so here what happens is that once you have the warm air which tends to move into the area of the cold air and vice versa, there is that zone of transition which is created. And that zone of transition is what is known as a front. Here you can observe that the cold air, think about it as the cold Arctic air. And here you have the warm air. Think about it as the warm air brought by the region of the Gulf Stream or the movement of the Gulf Stream. So here what you observe is the creation of a front. Now fronts can be of various types, warm front, cold front, etc. But when you have such a frontogenesis which happens, there will be creation of a low pressure. Why? Why will there be a creation of a low pressure? Because, think about it, let's suppose you have a column of warm air. Now warm air is the one which is lighter. Warm air will be ever so expansive, will have a greater volume. And let's suppose you also have the region of colder air. Now cold air having lower temperature will be significantly much more compressed. Now let's suppose the warm air tends to move into the territory of the cold air and the cold air tends to move in the territory of the warm air. Let's suppose any of the case which is happening. You have to understand that regardless of whether it is the warm air moving or the cold air moving, eventually as this moves, the warm air gets lifted upwards. Why? Because the cold air, being the compressed one, having a very restrictive volume, cold air will always stick closer to the ground. Why? Because the cold air is heavier. Due to the greater density of the cold air is going to be significantly and substantially heavier. So it will stick closer to the ground surface. It is the warm air which will start rising up. Now, as the warm air starts to rise up at the boundary, what will happen? What will happen to the pressure? Think about it. When we say atmospheric pressure, we talk about the weight of the air column imposed on the surface. So if you have a rising air parcel, any air parcel which starts to rise up, means that weight on the surface is getting lifted because the air is rising up. So whenever that pressure reduces, automatically there is that creation of that low pressure. So that is where here you will observe the creation of that low pressure. And what happens around that region of low pressure? Winds always blow from a high to a low. So remember that. Whenever the winds will be in motion, they will always be attracted towards that low pressure. Low pressure acts as that magnet, if you can think about it in that way, which will attract winds from all directions. But we are talking about the region around 50 to 60 degree north latitude, where the Coriolis force will also be particularly strong. So around that region of low pressure, let's think about that region of low pressure as the winds are approaching this low pressure from all directions. We are talking about the northern hemisphere. So as per the Coriolis effect, the winds will bend in the rightward direction. So all the winds here, they will start bending in the rightward direction. So the circulation around the low pressure that you attain or that you achieve, that circulation around that low pressure will be somewhat like this. What is that? Anti-clockwise circulation, isn't it? So there will be a very strong anti-clockwise circulation around that region of low pressure. Something that you can see even with the help of this particular animation. Observe the circulation here. Observe particularly around the center. Observe how the circulation takes an anti-clockwise route. That is the germination of the storm. That is where around that region of low pressure, the winds will start to rise up. And as these winds, they start to rise up, then what happens? The warm air is getting lifted up. But here, the air is getting lifted up from the region of the water body, that is the Atlantic Ocean. And that means that rising air will carry significant amount of moisture in the process. As they are circulating, that rising air will carry huge amount of moisture. So think about it. If let's suppose this is the region of low pressure, as the winds are rising up, they will carry moisture. And that is where condensation will happen, releasing that latent heat of condensation, further accentuating the low pressure, and there will be a development of a full-fledged storm. But this particular storm will be present. Why? Because there is a difference in temperature between the cold air and the warm air. As long as this difference in temperature is very significant in this entire area, that storm development will be very, very accentuated. Around this low pressure, you can see that the air is rising up. And what is happening on the ground surface? The cold air is slightly and slowly and steadily sweeping the entire area. So whether it is the cold air which is moving forward or the warm air which is moving forward, the outcome is that on the ground surface, as compared to earlier, you observe that it is the cold air which is slightly progressing. Means what? That the temperature will drop on the ground surface. So due to that low temperature, ground surface will have very, very low temperature. And as a consequence of that low temperature, even if there is any precipitation, that precipitation will always occur in the form of snowfall. That is why here you will observe such significant amount of snowfall happening. Why? Because of low temperature. Why low temperature? Because of cold air covering and enveloping the ground surface. So that is how these storms will develop. And these storms will magnify. You know, these particular storms, they can exist for multiple weeks together, depending upon the strength of the Arctic winds, how strong and regular these Arctic winds are. This front can continue to be in existence. And because this entire circulation is happening across this wider front, so think about it. Here also some warm air will rise. Here also some warm air will rise. Here also some warm air will rise. So in this entirety of the area of the frontal formation, there will be a cyclonic circulation, which shall develop, a storm-like circulation which shall be developing. And that is why you will observe these nor'easters or these extratropical storms to occupy such a wider portion. They occupy such a wider area. Okay, so that is basically the association with these particular storms. These are your typical nor'easters. But such kind of storms in the region of Atlantic, you would have also have heard about hurricanes. So are these storms and the hurricanes the same, or are they different? The answer is they are very different. Even though hurricanes are also storms, these nor'easters are also storms, but they are different. How and why? So basically, the second image that you see, that is the image of a hurricane. Hurricanes are nothing but a typical tropical cyclone. Tropical cyclone. And what you see as nor'easter, these are basically your typical extratropical cyclones. So these extratropical cyclones, they exist for a longer duration. And these nor'easters, by the way, think about it, this entire circulation means the winds will also be blowing with a very great speed. And that is why these nor'easters are such unique events where the wind speed can have a destructive and a very distinct destructive power or a destructive force. And that is why across the coastline, you will observe coastal flooding, coastal erosion. In case there are sandy beaches, there will be coastal erosion, huge precipitation, and very strong wind motion. So it is an extratropical cyclone developing over a large area, and this is a tropical cyclone developing over a small area. Hurricanes will end up developing over the water body in itself, whereas these nor'easters, they tend to magnify itself and amplify itself due to the cold terrestrial winds as well. We have seen that the cold terrestrial winds brought by the jet stream from the region of central and western Canada, they also end up accentuating this particular storm. So that is how these nor'easters are very, very different from a tropical cyclone that you would have studied in the portion of hurricanes. Now, till when do these nor'easters or these extratropical cyclones exist, or till when will they last? Here also, you have to understand that as long as the front is in existence, this will continue to last. Eventually, the front will dissipate. There will be frontalysis. There will be the occluded front which will be created, and the entire cyclonic circulation will come to an end. So these nor'easters are there to stay for a few more days, and they will continue to wreak havoc in the region of eastern coast of North America. And again, I will repeat, in order to understand these in greater detail and the extent of that frontalysis, that creation of an occluded front, that is why we will be conducting a special session particularly directed towards that in the special classes. Now coming to the climate associated. What is the climate that you generally associate with nor'easters? So nor'easters can produce heavy snow and blizzards. They can bring about, now what are blizzards? Blizzards are basically cold polar winds which carry powdery snow along with them, moving at a speed of anywhere close to around 80 to 100 km per hour, reducing visibility and carrying the temperature to sub-freezing level. So any form of precipitation which occurs or happens will be in the form of snow. That is why it is much more destructive. Rain and flooding and huge crashing waves, or the creation of what we refer to as a storm surge. Storm surge is when you have very strong winds bringing larger waves crashing into the coastline. Now these waves can cause erosion at the sandy beaches and severe damage to the nearby structure, permanent or temporary. They can produce wind gusts that sometimes are even stronger than the hurricane force winds. So you can think about that how much energy these nor'easters can carry. So overall, in this particular video, what have we discussed? What are nor'easters? Where are they formed? Why are they formed? What are the stages and the process? What are the factors involved here? You have the ocean current, you have the jet stream, you have the Arctic winds. All of them in that strange confluence end up creating that perfect storm. Perfect storm not in terms of its outcome, but what the famous adage goes by. And this will continue to exist for as long as the front is in existence. Till when will the front be in existence is as long as there is that unique temperature difference. Why does it occur only in the winter months and not in the summer months? Because it is in the winter months where that difference in temperature between the polar air and the tropical air is more exaggerated. During the summer months, that difference in temperature still exists, but it is not as exaggerated as we observe during the winter months. That is why whenever nor'easters hit, you will observe it is generally in the case of January or in the month of February. That too in the first half of February. Okay? So what kind of questions can be framed from here? You can have a mains type of questions being framed from here. For example, about what are nor'easters, discuss about the formation of a temperate cyclone. Because regardless of whatever name you call it by, this is nothing but a very significant and a powerful extratropical or a temperate cyclone. So UPSC tends to attack you at the basic concept associated with the portions which are in news from the area of current affairs. So I hope that this is now understood, and in this particular area you won't find any problem whatsoever. So here, this is where we'll end the video, but before that, an announcement for today's special session. So today we are going to have the special sessions by history and for history by Abhishek sir, and for geography we shall be discussing the nor'easters in greater detail about the entire process, why frontogenesis happens, why frontolysis happens, what is the entire duration of it, what is the direction of movement, everything we shall be discussing in greater detail. So join us on the app for a greater understanding of these particular topics. We shall be bringing you the topics and various different subject related issues for the portion of current affairs, be it any international conventions or laws in the portion of environment, or be it the portion of geography. For example, atmospheric rivers, for example, lack of winter snowfall in Jammu and Kashmir. So do look out for the series of the geographer and join me for the next particular video. If you have liked the content, please don't forget to click on the like, share and the subscribe button. Till we meet again, take care of yourself. Goodbye. Thank you.